Hello, you're welcome back to Quiver Analytics, and in this video we want to talk about t-tests, the three types of t-tests. All right, so the first one is the one sample t-test. I'm just going to give a brief explanation. The first one is the one sample t-test, where we have an hypothetical value to test if truly a population characteristics, which must be a a numerical variable, that's scale variable or integer variable. We have an hypothetical value that we want to test if truly the true mean lies within that area or not. All right, so that's one sample t-test. We'll practicalize that very soon. Second, the second t-test is the dependent sample t-test. Now, the dependent sample t-test is where we have the before and after, mostly what is called in marketing A/B testing. All right, so we'll show you how this is done, how the dependent sample t-test is done in just a single code. All right, now where we want to test something was maybe we want to test the state of something before an intervention was applied, then we test the state again. For example, before exposing a group of women to um, to the gym, their weights were collected and BMI. Or let's just talk about their weights. The weights were collected. Now, after the intervention, which is say 3 months in the gym, their weights are collected again. So to test the before the gym experience and after the gym experience is called independent. The samples are the same. Like the people that were tested or the objects that were tested in the first experiments were also the same people that were tested in the second experiment. So we want to see, is there a significant difference between the two? If there is, then that intervention has worked. If there is none, then the intervention has not worked. There's always an intervention between the two. All right. So we can give a group of students tests before actually taking a course. After the course, we give them the same test to attempt, and we test if there's a significant difference. That's in testing the efficacy of the teaching method or the teacher. All right. Now, while the third one is the independent sample t-test. The independent sample t-test, where you have two different groups of participants or objects or people, and we are testing them for the same measure. For example, we want to test if the gestational weeks between male and female children are the same, or the birth weights of male and female children, if they are the same, the mean birth weights rather, they are the same. So t-test is a test of different means, mean differences. Is there a difference between the means of the groups? All right, so let's go into it now. For this data sets, the integers we have here are month age, gestational weeks, and birth weights. So let's see. Okay, let's go back to graph and see histogram for each one of them. So one of the assumptions of t-test is a parametric test. So we check for month age. So we check for um, normality. All right. So let's see density, number of beans. We leave it at 10. Blah blah. So there are no options here. We submit. So we are still using the log file. The log file we opened. So this is good. This shows that you can see the apex here, the kurtosis, while um the symmetry is symmetric. All right. So pardon that. So now let's look at gestational weeks. We should have the same thing. Okay, the gestational weeks a little bit skewed to the left. Okay, which can be still good. At least it's not bimodal. It's still. Then the birth weights. Let's see. All right, so the birth weight is also good. That's visual inspection of normality tests. All right, so these are good. Now for the first t-test, this is birth weight. Let's see, mean. Okay, statistics, summary tables and tests, summaries and descriptives. Let's see, means of max age, gestational weeks, and birth weights. All right, then okay. So the mean for max age, mean estimation number of observation equals 64. So the mean for max age is 33.97. The gestational weeks is 38 points. The birth weight is 3,129 grams. All right. So now let's assume there's an argument that the maternal age is 35. So let's see if, all right, let's see if this is true. We want to test that the assumed mean is 34. Okay, let's say 34 because the approximate here is 35. 34. Now, how this works is that there has to be an hypothesis. So, for example, if the WHO has made a survey, or the United Nations has made a survey that the maternal age, the average maternal age of mothers in Africa is 19, for example. So now let's test if this is true given our own population. All right, that's the population here. So we write t-tests. It's a simple command in Stata. T-tests. So what are we testing? You can select maternal age from here by double clicking. All right, then we have the double equal to, that's the logical expression, a logical expression or a logical function to test if it is true or false. So we want to test if it's 19, then enter. Now we have observations, the maternal age, the mean, the actual mean. This is the actual mean. Then our null hypothesis that it is 19. Then this is what we interpret, 0.00. This means that it is not 19. So we reject the null hypothesis. We reject the null hypothesis and we say that the null hypothesis says that it is 19. Then we reject the null hypothesis, where we accept the alternate hypothesis that it is not 19. Now the average maternal age is not 19. All right. Okay, so let's go to the second type of t-test, which is the dependent sample t-test. The dependent sample t-test is one where we have the before and after, which is called the A/B testing in marketing. Now, before and after, in the example in marketing, when you have a marketing promotion that is targeted in some way, you have the same marketing promotion targeted in another way. So you want to check if there's a significant difference between the two. Now, because we don't have such data here in our baby's data, we are just going to assume we are going to use the maternal age and gestational weeks if there's a difference between them. Actually, because why I'm using the two is because the maternal age, the average is 33, while the gestational weeks, the average is 38. They are still a little bit close, but they are not the same concept. All right, so we have t-test again, simple code. T-test, is that properly written? We have t-test max age, okay, I don't have to write it. So I try to avoid writing the variables to avoid error. Okay, max age is the same as gestational weeks, right? So we press enter, and here we say it is not the same because again the p-value is is less than 0.05, which means the test is significant, and we reject the null hypothesis and accept the alternate hypothesis that it is not the same. That means it is not zero. One is significantly greater than the other. That means gestational weeks is significantly greater than maternal age. So if there's a marketing promotion that is the second one, the second marketing promotion, the second targeting is significantly greater than the first one. All right. Now the third type of t-test is the independent sample t-test, where we have two different groups of people. It could be a case control study. It could be an intervention study, like I explained earlier. It could be between male and female, or two groups that the two groups must fall in the same universe. You can't go and bring two groups that are different. You can't bring a group of lion and a group of rats. That won't be logically correct. All right. Numerically it might work, but logically it is not correct. So in for our test, we want to test B weights. Okay, I said I don't like typing, just to avoid errors. So now we want to test if truly the birth weight is the same among male and female babies. Is there a significant difference between the male and female babies? All right. So our null hypothesis says that difference equals zero. That means there is no difference. While alternate hypothesis says difference is not equal to zero. Now, this is 0.0012. It is less than 0.05, which means that there is a significant difference. That's it is not zero. There's a significant difference between birth weight of male children and female children. And that means that 326 is significantly higher than statistically and significantly higher than 315. All right. So that is for t-tests. In this video, we've seen the one sample t-test, the dependent sample t-test, and the independent sample t-test. T-test only applies the highest for two factors or two levels. All right. So we can also test for hypertensive condition of mothers and birth weight if it affects, or if there's a significant difference between them. All right. So thank you for staying with us in this video. Don't forget to like and share and subscribe to this video. Thank you. See you in the next video.